Hey, welcome back. So today we're looking at kind of our next mathematical piece. We've talked about pH, we've looked at acid-base chemistry. Our next kind of big math skill is going to be our titration reactions. Big fancy word, but don't worry, it's pretty straightforward when we stop and think about it. We have all the skills we need. We just need to apply them in a slightly different way. So by definition, if you're to look it up in the textbook or online, a titration is just a lab technique where a solution of known concentration is added to a measured volume of an unknown concentration until some endpoint is reached. Oh, there's a new word in here too, endpoint. Endpoints are marked by a color change of an indicator. We know to stop at the endpoint because it changes colors. All this to say, all we're doing is using our knowledge of chemistry to figure out an unknown concentration. We got this acid, we don't know how concentrated it is. Okay, well, we'll add some base to that to figure out what that concentration is. That's all we're doing. We're figuring out a way to find an unknown concentration. Now, endpoints, we got to use those because that tells us where we've neutralized everything. If you remember, our indicators change colors depending on if it's an acid or a base. And so if we had, say, an acid that we were titrating with, and we put a little phenolphthalein in there, it would be colorless. And then we'd slowly add a base, until the color change just barely changes to that pink color. That tells us, hey, you've used up all the acid. There's no more acid in this beaker. And so we can stop our titration and say, okay, how much base did that actually take us to get that color change to occur? Don't worry, we're going to look at examples. We're going to be practicing quite a bit. My goal today is just to get you the mathematical piece so that we can be practicing. We'll talk more about the theory when we're all back together. Good news, for solving these problems, there's three steps. And two of the steps are kind of the same. Step one, you're going to use your molarity to find the moles of whatever it is you added. So usually if we're adding a base in our example, we know its molarity and we can measure its volume. We know how much of that we put into there. And so knowing that, we can solve for the moles. How many moles of base did we put in there? Then we're going to use stoichiometry. We're going to use our mole ratio from the balanced equation to go from moles of what we know to moles of what we don't know. Usually it's a 1-to-1, not always, but usually. And so we can mole ratio, we've done that before. Then your third step is to use these new moles that you found using your ratio, and the volume that you measured out originally, you can solve for your final unknown concentration, because we can actually measure out how much did we of this unknown acid did we measure out. Okay, we measured out 25 mils. We know its volume. And we just figured out how many moles are in there because we know how many moles of base it took to neutralize it. So all this to say, we're going to molarity, mole ratio, molarity again. Not too bad. We just got to keep track of our numbers. Let's take a look at an example so that you guys can be practicing some of these calculations on your own. So here's what we got. We have some sodium hydroxide, and we don't know its concentration. We're going to figure that out. And we're going to do that by neutralizing it with our acid. And that one we do know. We know its molarity. We know its volume. We can solve then for some stuff we want to figure out then, and that's all that our titration problems are. We're going to figure out what is the final concentration of that unknown sodium hydroxide concentration. Well, it's chemistry, right? Always start with a balanced equation. We got hydrochloric acid reacting with some sodium hydroxide. Acid plus a base is going to make, hopefully you just said, water and a salt. Good news. Oh, that's nice. Ratio is going to be 1-to-1, I think. This is already balanced straight up. It's all ones. That's awesome. Cool. Sometimes I like to list what I know from the problem. It just makes it easier for me to see what's going on. Well, we know we used 25.2 milliliters of the acid. Oop, that's a W. Milliliters of the acid. And we know it has a concentration of 0.0998 molar. I'm just listing what I know about. So that's what I know about my acid. For my base, I don't know its concentration. We're trying to find its molarity. But we do know that we used 35.62 milliliters. Now, if you remember, we said we're going to molarity, mole ratio, molarity again. Well, molarity is moles, molarity equals moles over liters. Well, what do we know? We know enough about the acid. We know the milliliters, we know the molarity. We can solve for the moles. We got to do a little work though. Move your decimal over 3 spots to get it into liters. If we know our molarity and our liters, we can solve by multiplying to get the moles. So we're just going to take our 0.0252 liters and multiply by our 0.0998. When you do that, you get this little stinking tiny number. It comes out as 2.495 times 10 to the negative third moles. Well, moles of what? This was the volume and the molarity of the HCl. Here's how many moles of acid we had to put in to completely neutralize, to use up all of the base. But good news, everyone. It's a 1-to-1 ratio. Our next step, step 2, is your mole ratio. And I know it seems silly, but it's got to change our moles, and it won't always be 1-to-1. We use our mole ratio to cancel our moles of acid, gets us into moles of base. It's going to be the same number. You're right. 2.495 times 10 to the negative third moles. But now it's moles of NaOH. We just figured out how many moles of particles are floating around in there. And we know the volume that we measured out. Oh, step 3, molarity again. We do need to change this into liters. Boop, boop, boop. Molarity equals moles, which we just found, 2.495 times 10 to the negative third, divided by the liters, 0.03562 liters. When we divide those, we get 0.0700 with 3 sig figs molar. And hopefully this makes sense, right? If you're thinking about your original volumes, you had a larger volume of the base than the acid. So the acid must be more concentrated than the base. And this is what we see. The acid concentration 0.09, almost 0.1 molar, and our base is only 0.07 molar. So this is our process: molarity, mole ratio, molarity again. Whenever we're trying to solve these calculations, you try some on the handout. We'll start with questions coming back when I see you again.